Hey, everybody, welcome back to the Doctors in Podcast. I'm your host, Dr. Nadia Saba, president and founder of Dr. Greenhouse. Today, we are going to talk about three fundamental uses of data at your controlled environment agriculture facility. There's been a lot of talk recently about how to use automation to reduce labor or increase efficiency or to detect crop deficiencies and diseases. We also hear a lot of talk about using AI to operate an autonomous greenhouse, apply precision and predictive controls, or just to be a virtual assistant for a grower. While I for sure believe that automation and AI have a place in CEA, um, and the agriculture sector at large, there is one sort of common denominator that I feel like gets overlooked too often in these discussions, and that's data. In several recent studies in the cannabis industry and the vertical farming industry and greenhouses, uh, surveyors asked growers, are you collecting or analyzing data at your CEA facility? And what has been really surprising to me is that, nearly half of operators are saying that they do not use data, they're not collecting or analyzing data to support their ongoing operations and decision making. They might look at data instantaneously and in the moment, but they don't necessarily have a robust system to collect it, record it, and analyze it. And I see this a lot, honestly, with some of the facilities that I've visited, that I'm helping growers to improve their operations, is that we walk into a room and the first thing they do is look at the thermostat on the wall, and they literally will make a split decision. Recently, I visited some mushroom farms, and they have like a running sheet, basically record sheet outside the room, where every time someone walks in and out, they look at that thermostat and that relative humidity stat, and they write it down the time, and then they write down what the temperature and humidity are, and then they move on. And that is their tracking method. Um, and doing that, right? Go walking into a room, looking what the temperature and humidity are, that is what sort of develops the grower's feel for the space, right? Feel for what the plants are doing and how they might be responding to their environment. But when we're talking about, data-driven decisions, and we're talking about automation and robotics and AI, we have to base that off of more than just a feel. And so, I really wanted to talk today about what I think is fundamental to agriculture, to science, to being a good grower, which is, what do we do with data? Why is data useful just in our everyday tasks and work? You know, Yes, we can talk about how we can collect gazillions of data points and all the types of data that we would need in order to automate a process or make a system more efficient. But first, we just have to understand what data is and how we can use it right now, so that we can think about how it can improve our lives potentially in the future with these very expensive and complicated machines. Okay, so let's get to it. So, what is data anyway? Right? So, data is really the raw material from which information and knowledge is derived. Some people call data information, but in my thought, in my opinion, we don't really extract information from data until we evaluate it, right? Until we think about it, until we put some value to it. Otherwise, data is just a point in time or a point in space. And we use that raw material to measure something, to calculate something, and to evaluate, right? To evaluate the world around us. Now, obviously, I speak in right around HVAC and climate control for indoor farms and greenhouses. And so I'm thinking about data in terms of temperature, relative humidity, carbon dioxide concentrations, light levels, irrigation volumes, and quality, right? All of these various variables that are going to tell me how the plant is responding to its environment and what I might want to do now and later to improve the response of that crop to its environmental inputs. And that is something that I also want to just mention is that data can be both an input and an output. And the way that you might think about it, growers, is that a data input is saying, I want, this temperature target, right? You have your control system, whether it's just a little, thermostat in the room or whether it's a big, robust, BMS system, you are going to set what the temperature is that you want in the room, day, night, this crop, that crop, right? That is a data input. The output is what you actually get, right? The actual temperature that is observed and measured, right? It may be very different from what your input was, right? From the desired temperature. You might have wanted 80 degrees and the output says it's 90 degrees, right? So there, right there, you have two data points that you can compare, right? An input data point and an output data point. Okay, so now that we all have kind of the same fundamental understanding of what data is, let's now talk about how data can be used in CEA every day, regardless of what type of system you're using, or if you're just using yourself as, the system that's monitoring and analyzing data. Okay, so number one fundamental use of data in your CEA operation, monitor. Let's monitor the current conditions in your room, in your greenhouse bay, right? In whatever production space we're dealing at. And so to monitor the room, first of all, we need to look at the sensor readouts, right? So what is this temperature sensor saying versus this temperature sensor versus this temperature sensor? Now, let me just start by saying, hopefully you just have one reliable temperature sensor or multiple reliable temperature sensors, and you're not looking at all these different sources of output readings. So the first thing we're doing, right, is we're monitoring what's happening in the space right now. And the reason we want to do this, right, is we want to first we're going to ask ourselves, is this what we expected? Right? Is this the condition I expected or wanted, right? If I said that I want it to be 75 degrees in this room, am I getting 75 degrees? Why or why not, right? It's sort of a split decision, split thought, right? Of what is happening now. Is there a problem? Is there an alarm? Is there an anomaly? Right? So one of the challenges that because monitoring a room just gives you sort of an instantaneous snapshot is that sometimes it can be hard to recognize whether or not there's an anomaly unless there's a bigger problem, right? Because we're only going to see what's happening right now. We weren't paying attention to what happened before or after. But what's really good about monitoring the room, walking into a room, looking at the sensor, looking at the plants or the crop, right, is that it gives you that feel, right? That feel for what is right or what is wrong, what's working, what's not working. Are the plants, do they look good? Do they look like they're struggling. And the other thing is that it can kind of give you a sense of, what sensors are useful, and what sensors maybe we don't need, right? So, you see this image behind me and there's actually a few more sensors off screen that you can't see in this photograph. And it was mind boggling because, every single sensor that we use to monitor temperature had a completely different readout. It could have been plus or minus half a degree, but we saw plus or minus 3 or 4 degrees. And so in recognizing that, it was like, okay, which of these sensors is really giving us the readout that is accurate and the readout that's also maybe signaling to some other piece of equipment to right to operate to send a command and say do this. We want to make sure that that is the right sensor for running that piece of equipment, but we also want to make sure we're not looking at a different sensor, because then we might react differently than what the equipment is going to respond to, and that may or may not be beneficial. Also, all these sensors you see that we have, in this photograph, we're all trying to take, you know, the temperature at the same exact location. But some of these sensors might be more exposed to these lights. Some are more in the canopy, right? And so there's this sense of where the sensor is located, what type of sensor is going to be useful, and just when you want to monitor the room, which, when you're making observations about your grow room, you probably don't just want to look at the temperature one time a day, right? We're probably wanting to observe conditions throughout the course of the day, maybe when the lights are off, when the lights are on, in the morning, at night, during ramp up, ramp down, right? And so all of a sudden, when you start to think about how many observations you need to make to get a complete picture of the room, this is when you might start to say, okay, I need to do more than just walk in the room or stand at a remote computer and see what's happening now. Maybe I should do something with this data to make it more useful in the long run. Okay, so this brings us to the second fundamental use of data, which is to collect and record that data. Now we're not just making an instantaneous observation and saying, oh, the temperature looks great right now, or oh my God, the temperature looks horrible right now. Now we're saying, okay, now I'm going to collect temperature data over the course of a day, over the course of a week, a month, a year, 10 years. I'm going to also put sensors at 3 locations within the room, or 5 locations, or at different levels in my vertical farm, right? And so now what we're doing by collecting data is that we are creating a history and a map of what is going on in our room, when and where. You know, we basically are trying to figure out what data do we want to save for later, right? So we know that we monitored the room, right? And we took measurements 3 times a day, right? And then right when the lights turned off, because that's about the time I'm going to go home, in the middle of the day, and then the morning when I arrive in the facility, just to make sure things haven't gone awry since I was gone for a few hours to get some sleep. Um, and now what you can do, right, is you can say, okay, well, I have those 3 data points and I kind of have an idea of what's going on, but I really want to know what's happening when there's an irrigation event, or I really want to know what's happening when the team is in the room pruning the plants, right? Or high wiring the tomato vines, or just, doing work in that space. Or maybe I want to know what's happening on this really cold day. Oh my God, we had a cold snap last night. I want to know, was my room able to maintain the temperature that I had set for it, when on a 50-degree night, that was no problem. But last night it dipped down to 20 degrees. Did the room hold? Right? If you're just monitoring the room, if you're just doing instantaneous observations, right? Like, yeah, I guess you could do that for, if you have sort of like a remote Bluetooth type monitoring system, you can be sitting in bed and like, clicking and checking to see what's going on in the room. But it would be nice if you guys could get some sleep. And it's also, what are you going to do with that information if you're just making that observation from your bed? Do you actually have the ability to make a change in the field, to call someone to say, hey, something's going on? It's great if you can make an instantaneous call or command to make a change. But what you might not realize is that the heater hadn't quite kicked on yet. And that, it's ramping up, and that an hour later or 10 minutes later, oh my God, you hit the temperature. But you just happened to look at it right before the heater had gotten up to full capacity, right? And so now the rest of the night, everything was fine. Now, it might be still interesting to know why you weren't hitting the temperature sooner, but maybe you also didn't have to worry and not sleep throughout the entire night because you thought the room was going to be too low the entire time, when in fact it was just a lag in the response of your heating to warm up and heat the greenhouse. If you were collecting and recording that data, then the next morning you could arrive at the site, right? And you can look at the trend data and say, oh, this is what happened, right? There was a dip in the temperature, and then the heater kicked on and everything was fine for the next 8 hours. So that's one of the things that's really helpful about collecting and recording data, is that you create this history and you create this map if you have, sensors positioned in several locations. And it gives you an idea, of how much data is too much data, how much data is too little data. In the example I just gave, if you were collecting and recording that data every 5 minutes, you might see that the heater was ramping up really quickly. If you only collected or recorded data every hour, you might think for an entire hour it was too cold, and then all of a sudden it was perfectly warm. So figuring out kind of the frequency of how often to collect and record that data is really important. And I'll tell you, it's probably different than just the instantaneous readouts of that sensor, because the sensor is going to continuously, almost infinitely, be reading a temperature, but you don't want it to record every half second time step, right? We need to find some logic into how frequently we would collect and record that data. Okay, so that is the importance of collecting and recording data. One, honestly, is just to give you guys some sanity. All right. Okay, so number three, the third fundamental use of data at your CEA operation is to analyze that data, right? So now we've collected and recorded these data over time and over space. Now what do we do with that data, right? Now we want to see if there are relationships. We want to understand why the inputs differ from the outputs, or why they were the same for that matter, right? And so we want to analyze data in order to improve conditions, to optimize our operations, and to just know if we need to make adjustments or just maintain the course, right? Because everything is working fine. And so, analyzing data is something that I really love to do. In some ways, I would consider it one of my superpowers. I really like looking for the blips, for the anomalies in data, and pointing at that and saying, what is happening here? Right? What is happening here? And what you can't see is that this is an energy curve. For those of you who have taken my workshop, you've probably seen this graph before, because it's a great example to say, everything is really chill, right? Everything is really flat, right? There's light and there's HVAC and there's the relative humidity and the temperature, but there's this line, this blue line that is increasing over time. Why? Right? Why is that happening? And that is one of the beauties about analyzing data, is that if I just happened to observe data at this point and then observe data at this point, I would have no idea that there was a change in between. Right? I looked at it when I got to the office, and I looked at it again before I left, and everything looked kosher, right? Everything looked the same. But because I collected and recorded data and I put it on a chart, in a graphic, I can now see what trends are happening in my room. By the way, if you have to know, actually, you know what? Contact me if you want to know what this blue line is that's increasing over the course of a day. I will give you a hint. This is an indoor farm in Sacramento operating during the summer. Okay. So anyway, by having this data now, right, and we can plot this data, we can say, what the heck is going on, right? Is the data consistent from day to day, from crop to crop, from greenhouse bay to greenhouse bay, from team to team? Why or why not is it consistent, right? Are my outputs, right, the temperature that I'm reading, equal to the temperature inputs that I asked for in my control sensor? Um, and so by asking these questions, we can start to develop these cause and effect relationships. And it's not always bad, right? I want to be clear, like, we're not just looking for things that are bad. Sometimes we're looking for things that are good, right? I mean, sometimes those blips are actually an unexpected surprise, right? A happy accident where that blip is actually an increase in, say, yield because the temperature went out of range, right? I mean, I'm sure there's a lot of cannabis growers out there that this happened to that maybe didn't listen to some people who said, yeah, increase the temperature when you switch from HPS to LED lights. Is that, now we don't have as much radiant heat coming from those LED lights. And so, in order to maintain the leaf and plant temperature, we need to add heat in a different way. And to do that, we do that with the surroundings, with the air, rather than this radiation coming from the lamps that is no longer there. And so, convincing growers that it's okay to raise their temperature from 75 to 80 degrees is not always easy. But I bet that there's more than a few growers out there whose HVAC system shut down, a compressor failed, and they have LED lights, and the temperature starts ramping up to 80 or 82 degrees, and they start to notice, right? And they haven't been able to fix the compressor yet for various reasons we don't have to go into here. And the grower realized, oh my God, my plants, right? They just grew through the roof, to use that term, right? Like, oh my, like they produced 25% more yield because the temperature was 80 degrees. But you would never know that, right? Like you might have a feel. You might say, oh my God, this room, it's been, every time I walk into it, the temperature's and creeping up. And your hypothesis might be that the plants are going to suffer, that they're going to be more stressed, right? And they're going to be less productive. But by the end of the crop, right? And you take those measurements, you're like, oh my gosh, my grams per square foot was higher when my HVAC system failed than when I was running perfectly at 75 degrees. And now what you can do is you can actually attach data to that outcome, right? As opposed to just a feeling. Because now if you have this feeling and you go back to ownership, or you go back to the director of cultivation, or to whoever, and say, hey, the temperature was higher, and we got these higher yields, they might just think that you're crazy because, like, well, show me the data, right? Show me the proof. And you're like, well, I took these measurements and they're scratched in my notebook, and they might not believe you because for the last few years they've been running at 75 degrees just fine, and they might think it was a strain, a better strain, or they might think that something else happened where you might have data. And so this is kind of where we get to this concept of data driven decision making, right? Data supported decisions is when you have that record, when you analyze that data, and you can attach, a cause, or a cause to an effect, right? Higher temperatures was the cause that affected a higher yield. Um, Now all of a sudden, right, you have the proof to move forward, to stay the course. And the opposite is true too. And ultimately, what, observing data and collecting and recording data and analyzing that data, that is essentially applying the scientific method to growing your crop, right? We've observed a phenomenon, we asked a question, we tested it, and then we analyzed it. And then we say, did that work? Did that not work? And you repeat, right? Or you adjust until you get to the outcome that you're looking for. So, those are the three fundamental uses of data in a CEA operation. Number one, let's monitor the current conditions, get that instantaneous snapshot, develop that feel for the space, the feel for your operation, and, just know what's going on right now. Do we need to make a course correction, or are things seem to be going okay and as expected? Number two is, okay, now let's collect and record that data, save it for later, knowing that we want to analyze it and evaluate later to figure out what is going on. And in doing that, right, we're going to all you have to do is just observe the data over time. You don't even have to put a lot of thought into it, into analyzing it, and just to realize, does this data make sense? Am I collecting it at the right pace? Are these sensors in the right location? Is one sensor different than the other two sensors? Does that mean that the sensor failed, or that the sensor got wet, or that the sensor is in a bad location, or the other two are in a bad location, right? It just kind of gives you a better sense, right? We're starting to develop the science behind the art of that data. And then analyzing the data, right, to improve conditions, optimize your operations, and make data-driven decisions going forward, that will make your life easier and make your operation more profitable. So before we all just dive in headfirst into AI and into autonomous growing, let's first think about the quality of our data, how we're using our data, and what we then want to do with that data. Because to me, the next progression of this, once you have a feel for the room, you have a feel for your crop, you feel for the conditions, you've collected data, you know that, in terms of equipment responding or personnel reacting to what's going on in the room, and knowing why those things are happening, then the next step is, okay, now how do I plug this data in to a computer to make the decisions for me? And by the way, you might not want to let the computer make all the decisions for you. You might want to observe now the computer making those decisions. But that is a subject for next time. I hope that you enjoyed this podcast. If you have any questions, if you want to know what the blue curve is all about, if you have thoughts on how you're using data, or how you could be using data, or you just want support in analyzing it, please give us a call. Until then, have a great day.